Hi everyone, my name is Shrestha Kulkarni, and as part of the NLP group, I have been experimenting with word embeddings with an ultimate goal of trying to find topics from the cluster of words that I get from these word embeddings. So this is where I start. I start with the translated data set and do a sanity check, drop out some nulls and tokenize the text to get a token length, get some plots of the token length versus rating. So we see that rating 5. Reviews are pretty short and we have a lot of outliers. So that is what was expected. If we see the mean length grouped by the rating, we see the differences in the review length, and we see if we tabulate the rating versus the app, we see that we have a major class imbalance issue in terms of the rating 5 reviews and the rating 1 and 2 reviews, which I have considered to be negative. So the division that I have considered here is 1 and 2 as negative, 3 as neutral, and 4 and 5 as positive. And I have created these word clouds per app, per category, as in negative, neutral, and the positive reviews categories. So we see that the negative reviews here in app ways does not have the real words really popping out, and but the positive clouds are good, and this happens again with neutral. So neutral, in a way, it looks really similar to the positive cloud. The words that appear in the positive cloud also appear in neutral cloud. Now this pattern has been replicated across apps. So even for Google Maps, positive clouds are good, negative clouds are not so good. It doesn't show the real real words that say there is a problem. And the neutral clouds, here we go, shows the same kind of trend. So we have some problems that we know. Now I start with a basic model from Gensim package with the word-to-vec algorithm. So I split the data set into train and test, and then I create some unique tokens in the training set by removing some stop words, and then I pass it on to the word-to-vec model, and I use a skipgram algorithm. So given a pivot word, it spits out the contexts in which that word could occur in the text. So we see that it has created a vocabulary of 28,534 words. These are some of the words that appear in the vocabulary. So availability, quicker, glass, country, man, head, fainted, nearest. So and this is how the similarities have been shown. So if we try to find some words that are similar to good, these are all come out, so they look satisfactory. If we see some words similar to bug, these words come out. So bugs, glitch, problem, malfunction. So these also look satisfactory, but here is where it goes wrong. If we try to do a vector good minus crash, you would naturally assume that it is something bad. So it then but if we do that, the most similar vector that comes out here is good, delicious, indeed, which doesn't seem so accurate. So I tried another model, doc2vec, which I'll explain now. But this word-to-vec model, the future work could be doing dealing with the class imbalance issue, and maybe trying with the already trained vector, which from which Google has made available, which has been trained on some billions or millions of words, and see if that gives some improvement in the accuracy. Continuing from the word to vec model, I also experimented with doc to vec model here, and instead of using the memory method here, I'm using a distributed bag of words model, and I train it for a very limited amount of epochs, just 10 epochs, and I use the row indexes as the labels for each of the sentence. And after creating the model, when I examine the most similar documents to any particular one, like say most similar one to document 1 are these documents. So the row number 297, 547, row number 307, 252, these are the rows that are most similar to the row number 1, and if we examine one of these rows, they do look similar. So that looks promising, and continuing on that promise, I decide to attempt a clustering. So I take out the array of document vectors, and I use the k-means clusterer from the NLTK package, and I choose a minimal number of clusters, say 10, and when I try to cluster it, you can see the respective lengths of the clusters. So there are 11,707 documents in cluster number 0, 33,000 in cluster number 1, so on and so forth. Now let's examine the most common 15 words from each of these clusters. So we see that cluster number 2 has all 2 and 3 lettered words, not really any information. Cluster number 7 looks like a positive word clusters. Cluster number 3 is kind of a mixture of negative and positive words, and cluster number 8 again takes on with cluster number 3, and we can see that all of these clusters, they do not really represent any topic or any theme as such. There are a couple of things that may be going on. Class imbalance is one, maybe the tuning parameters are not good. I need to experiment with clustering algorithm as well as the number of clusters. Maybe if I increase the number of clusters, the results would be better. So that is the path that I am going to take for the next week, and see what results come up. Thank you.
Hello everyone, my name is Meghna and I've been working on sentiment analysis for the project. Our first goal was to calculate polarity scores for each review in the dataset. For that, I've used Vader sentiment analysis library in Python. And when I used the sentiment intensity analyzer function, it gave me a negative, neutral, positive, and compound score for each review. And to categorize the reviews into positive, neutral, and negative, I divided them based on their compound scores. So a review with compound score 0 would be a neutral review, and review with compound score greater than 0 would be a positive one, and less than 0 would be a negative review. To get a picture of how many positive, neutral, and negative reviews there are in the dataset, I created a pie chart. So it can be seen that there's about 60% of positive, 12% negative, and 28% neutral reviews in the dataset. So for the next steps in the analysis, I'm considering to train a classifier to predict sentiment of the reviews and compare the performance of the classifier with the Vader results. And another direction would be to see if there is any correlation between sentiment and rating of a review.